The sensitivity report in Excel is helpful in understanding the sensitivity analysis, but it has one major restriction. It only applies when there's one change of parameter at a time. But in practice, there are many cases where you want to change more than one parameters at a time. For example, in this example, maybe there are changes in this number 8 and number 5 at the same time. How can we know if the current solution remains optimal or not? In that case, we need a new rule. A rule called 100% rule. The rule basically says that the current solution will remain optimal if the sum of percentage change is less than 100% or less than 1. The sum of the change in coefficient divided by their allowable increase or decrease, if they add up to be less than 1, then the current optimal solution remains optimal. However, it's very important to understand that the rule does not say that the optimal solution will change if this condition does not hold. In that case, you really need to resolve the problem to see what's going on. So now let me show you two examples. Now let's look at an example. This is a sensitivity report for this problem. Now let's say we're going to change the coefficients at the objective function. We're going to change it to 9x1 plus 6x2. In other words, we're going to increase the coefficient here by 1 for both x1 and x2. Okay, so it's an increase for both cases, so we're going to refer to allowable increase in the next step. What we're going to do is this. We're going to divide the amount of change for the first term, which is from 8 to 9, so the amount change is 9 minus 8, which is 1, divided by its allowable increase. It's allowable increase because this term goes up. So allowable increase is 2 here, so it goes here. For the second term, the amount change is, again, 1 because it goes up from 5 to 6, so 6 minus 5, that's 1, divided by, again, allowable increase because it goes up. So allowable increase over here. You add these two terms up and out to be 67.6%, which is less than 100%. So we can conclude that the current optimal solution will remain optimal. Let me give you another example of the same problem. Now let's say our coefficients is going to be changed to 9.5 and 4.5. So again, we simply need to apply the 100% rule. Here is it. So we add up the percentage changes for both terms. For the first term, the coefficient goes up from 8 to 9.5, so the change is 9.5 minus 8, divided by, well, it goes up. So again, we need to refer to allowable increase over here, divided by 2. That's for first term. For the second term, this is for the second coefficient. It goes down actually from 5 to 4.5. So the amount changed is 5 minus 4.5. In this case, it goes down, so it decreases. So we now need to use allowable decrease for that coefficient, which is 1. And we add these two terms up. Turns out to be 125%. So we conclude that the optimal solution may change. Actually, we are not sure if it will change. We really need to solve the problem again to see if the optimal solution remains the same or is a different one.